Hey guys, we're going to go over the learning targets a little bit today. This is for Unit 5. I know it says Unit 2 at the top, but this is for compounds, ionic bonds, covalent bonds, reactions, and everything is based on the law of conservation of mass. So I'm going to do them one at a time and make quick little blurb videos, hopefully, that can help you guys. I'm going to start with number 1 and go from there. So if you're looking at your learning targets, basically, all that these are saying, the target itself is I can calculate the amount of reactants or products in a chemical reaction. And all that you need to be able to say is that what is on the reactant side is equal to what's on the product side. Okay? In other words, we didn't create it, we didn't destroy it. So remember that you can't create or destroy. Okay, we don't create things, we don't destroy things, we just kind of mix them up, mess them around, and make what we want out of it so that it's more usable or user-friendly for whatever our intended purposes happen to be. So, question 1 says the chemical equation above shows CaCO3 being heated. What is the total mass of the products if 100 grams of CaCO3 is heated? So, even though they're talking about this equation above you, it says this chemical equation above, because there were some questions about that, shows CaCO3 being heated. That's what's letting you know right here. This is being heated. What's the total mass of the products if 100 grams is heated? Well, what did you start out with? You started out with 100 grams. Well, if you can't create it and you can't destroy it, then you have to end up with how many grams left over? 100 grams. So here's your final answer. It really is that simple. Number 2 says when 127 grams of copper reacts with 32 grams of oxygen gas to form copper 2 oxide, no copper or oxygen is left over. How much copper 2 oxide is produced? So they're not saying that we destroyed the copper. They're not saying that we destroyed the oxygen. What they're saying is that copper in itself as a pure substance and oxygen as a pure substance are no longer there. What you're left with is a new substance, which is called copper 2 oxide. So what they want to know is how much is produced. Well, if you start out with 127 grams of copper, and then you add to that 32 grams of O2, you end up with blank amount of grams of CuO. Well, if you start out with 127 grams, you can't create it, you can't destroy it. How many do you have to end up with? 127 grams. You can't create it, you can't destroy it. We just change it. So even though we started out with a metal and a gas, we ended up with something entirely different. That's okay. That's what we get. The last one down here, number 3, says sulfur, which is S, reacts with iron, Fe, to produce ferrous sulfide, and that's pronounced ferrous sulfide, according to the above reaction. So they're letting you know that this is the reaction right here. How much iron is used in this reaction? This is no different than one of your basic math problems where you're solving for a variable. They're telling you here's sulfur plus iron yields ferrous sulfide. Okay, that's got a weird name, so that's not one we expect you to know how to name. So in this case, we started out with 32 grams of sulfur. We don't know how much iron we added, but we ended up with a total of 88 grams. Well, we can't create it, we can't destroy it. So if our total is 88 grams and we started out with 32 grams and some other unknown amount, put my gram sign there, then what do I need to do? Well, I just have to take away. I need to get this by itself, right? So minus 32 on this side and minus 32 on this side. 88 minus 32. 8 minus 2 is 6. I'll put my little g there. And then 8 minus 3 is 5. So you're left over with 56 grams of iron. So that should add up, and you can check your work by saying 32 plus 56. 6 plus 2 is 8. 5 plus 3 is also 8. And so we're looking for that number, and we got it. So there you go. I hope that you found that to be helpful.